Good afternoon, everyone. Good afternoon. Hi. I hear that you have an HSS exam at 5 o'clock. Yeah. Good afternoon. So yeah, we'll finish before that. I think we'll finish slightly much before that, and we have just a single topic to discuss today, and I think I'll give you the presentations and you can go through the specific details of it later. But we are just going to discuss like pointers about this topic. So it will probably get over very quickly, and there is so after that we so I was thinking that we could today I was thinking if we could do like a Microsoft Teams meeting with everyone on board, but I could not plan it out properly in the time. So maybe in between this module and before the next module starts, what we can do is we can have one day where we meet and we discuss if there are some doubts and all that. So let me figure out a good time for that. So what you can the volume is too low. Is the volume too low, everyone? Okay, I can increase it a little bit. Hello, hello, Mr. Mike. Yeah. So I was saying ki, in between this module and the next module, we can have like a small session, get together basically to discuss if there are some doubts in whatever was in all the lectures and all that. And also during this time, I will plan out a test and I'll try to conduct it with the tools that the institute is giving us. And I would want you to log in and create an account in this Code Tantra. The email probably has been sent to you, and I think Professor Biman Mandal has already tried to contact you and ask you to do it. So you guys should log in, create an account in that, and we'll try to execute a test in that. We'll see how it goes. If it works out, fine, we'll do it for the next test also. And if it doesn't work out, then we'll figure out another way. Okay. Right. Okay. Okay. So before we start off with today's topic, I want to go back to yesterday's session a little bit, and I want to specifically go back to the last slide. Uh, keep on going, keep going, keep going, keep going, keep going, keep going. Right. Okay. Okay. Thing is really Fayaz, I think you have to look at the email sent by Professor Biman Mandal or the academic section, if I'm not mistaken. What is happening? Right. So, just a second. Let me. This is what I wanted to know. This is not what I wanted to show. Just give me a second. This is what I wanted to show, and I have shared some videos for you to be able to do this assignment properly. But when I went through it, and I realized that there are a lot of things that need to be considered, and you need to think about a lot of details, and you need to improvise. This particular drop test specifically is not there as it is in Fusion 360. There is something called non-linear simulation, so you will need to do that to get this result. So I think there is a bit of a learning curve in that. So what I've done is this, instead of just being like a 7th assignment with both these components, I've divided it into two. First is to make the model, and the second is to do the drop test. Okay. I hope you understand. Just give me a hi or something like that. Yes, I understand, sir, in the chat boxes. Fayaz is asking a question. Since many of us had problems, they shifted the HSS exam form code tantra to forms. Really? Okay, okay. Tell me. So I hope you understand the changes in the assignment. Now we have, instead of just it being just the seventh assignment, it is seventh and eighth assignment. The eighth assignment being the results of the drop test. Okay. So explore it and see. If you are unsuccessful in doing the assignment, that means you tried all the setups and it did not work out for you. Submit the results as is. That means I could not do it. Try to find out the reasons why you could not do it. I think this was the reasons, but I could not figure out XYZ things. Okay. So submit those details, at least. I should know that you've tried to attempt it, and you have some limitations were there because of which you could not finish it. But I don't want you to just say, ah, sir, I couldn't do it. If you can't do it, show me screenshots. If I did this, I did this, I did this, but when I tried doing this, it did not happen. I followed the links and the ideas from the OneNote drive. So in OneNote, I put in specific videos, some tutorials and all that of how to do like this nonlinear testing. Okay. Anyway, so yeah, so this becomes the two assignment, and then uh, so uh, so uh, tell me what kind of problems you are facing with Code Tantra, and if I should do the tests in Code Tantra. Just write something like Code Tantra yes, Code Tantra no. Okay, Chaitanya is saying OTP is only for courses where instructors are using Code Tantra. Check with your instructor if they are using Code Tantra or assessment or not. If yes, then you haven't received an OTP yet. Then request your instructor to forward your details to Code Tantra team, asking them to register. CC me if need be. What is this, Chaitanya? Just tell me. Okay. Till then, let me set up for today's topic. Okay. Yeah. Uh, okay. The academic email. Right. Uh, so, so what I'll do is Code Tantra no. Okay. Others also, please type in your opinions in that, in the chat box, just for me to uh, take a decision. Anyway, so yeah, I can see the chat box. I put it in the screen on the side. So if you type, I'll see your messages. Okay. Yeah. So let's see. And there were some other problems also in the previous one or two lectures. What has happened is, I think I got some copyright claims from random people. One was from Apple, which I kind of guessed, but well, yeah, the video is sort of there. It naturally won't be monetized, but I think it's unlisted or something like that. But you should be able to access it from the links that you already have. Okay. Code Tantra no. Instead of privacy issues, what kind of privacy issues are you facing, and what kind of things are you seeing? Please tell me. Okay, till then we'll move forward. Just type in your comments about what kind of problems with Code Tantra are you facing. Okay, or what we can do is, no, just let me complete this, and then let's all come to teams, and we'll we'll do like a one-on-one session. Okay, we'll do like a discussion session. Maybe this is slightly limiting. Okay. Okay, what do you guys think about that? Just tell me. Okay, let's start off with today's topic just a little bit. Data is shared. all our data is well, yeah, data is shared with the government. I don't know, but I can't comment on this. Code Tantra, Fayaz is saying there is some network restrictions. Okay. Mm. uh, yeah, well, okay. Anyway, if you really think there are some serious privacy issues, then maybe we should not do with it. Okay. Why exacerbate the problem? Right. Okay. Anyway, okay. Let's start off with today's topic. And today's topic, we are going to briefly take a look uh, on glass and ceramics. So it's not a it's not a topic which is covered in detail in this course, but there are some ways of manufacturing that are there specific to these kind of processes, these kind of materials that we can look at. There are some things that we are not looking at in this course. These are composites, and we are also definitely not looking at plastics at all, which is a huge domain in itself. And if you are interested, I have if you are interested in learning about how plastics are manufactured and how what kind of different processes are there, what kind of different plastics and materials are there, and also you want to learn about composites and how composites are manufactured, how they are used in design, in product design, and how what kind of design considerations need to be there, then I will urge you to take the selective course on plastics and composites, which is, I think it's going to be in the next semester for you. I'm still unsure who will take the course. Most likely, it will not be me, but whoever, I'm sure one of the product design faculties who teaches product design courses, they will take it. Probably maybe Ravi sir, Supradeep, or somebody else. But in any case, that is the course where all of these information will be given to you. Okay. Uh, right. Amir, Code Tantra, Amir says Code Tantra requires mic and camera access, but modern Asus laptops don't have cameras. If they are modern, why don't they have cameras? It's a very strange thing to be modern and without a camera, but okay. Yeah, I mean, whatever. Uh, right, Gaurav. Okay. Right, so let's take a look at glass and ceramics. And this schematic diagram kind of gives you an idea about uh, the general process of manufacturing with plastics and ceramics. Okay, the first one over here, you start off with some raw materials. And what are the raw materials that you start off with to make glass and ceramics? Type in your comments. Type your answers in the comments. Okay, so you start off with some raw materials. You crush the raw materials to make powder, right? And then you add some additives to it. So some kind of chemical agents which impart certain properties to the raw materials once the whole product is made. Okay, so things like some binders, things to bind the crushed material together, some kind of lubricants, some wetting agent. Okay, so if you wet, so how sand is, no, so if you have dry sand, you can hold it, it just flows through, it almost behaves like a fluid, right? However, if you just put a little bit of water, it can hold some amount of structural integrity. Okay, it's very, like, you can make a ball out of a wet sand. Okay, but dry sand, naturally you can't do that. So things like that, wetting agents. And wetting agents are also some kind of agents which enable the enable the surface of these materials to latch onto other kind of materials. Okay, so some kind of bonding is enabled. Okay, plasticizers are another type of additives which makes the material flow better. Okay, and yeah, things like that. Okay, and then after the raw materials and the necessary additives are added, what you would do is you would give it a form, a shape, the final part that you want. Okay, so you do it in, you can do it in multiple manners. You can do it by very very traditional methods, like throwing the clay on a spinning disc and shaping it based on that. Let's say if you want to make something out of ceramic, some pottery, you could do some or one of these many processes, right? So you could naturally extrude. So if you make the if you are making a clay thing, a ceramic or a porcelain item, then you could extrude it through some, you know, shapes, and those extrusions you can kind of heat and you get those shapes, right? Press, you can press it. You can also injection mold it. Okay, there are some processes with modified machines, right, that enable you to injection mold these raw materials along with the binders into a shape, and then that shape could be later on taken to the next step. So the next steps, one of these steps are is drying. Okay, so you would dry the whole thing to ensure that almost 90% of the water, 90-95% of the water content goes away from this. So it becomes very hard and fairly brittle naturally. More I mean, it doesn't take too much to break this kind of a part. It's called a green part. Okay, and you could do some operations to this part also. So you could put it in a lathe machine, properly hold it in some manner so that enough undue stresses are not occurring on this part, on this green part, and you could, let's say, cut away some part, machine away some part which you were not able to do in the form shaping operation. Once that is done, you would take this whole thing, the green part, and put it in an oven, and you would sinter it. So that means you would heat this material to a certain temperature, depending on what material you are using, to a certain temperature, and you would hold it at that temperature for some time. And there will be internal chemical and structural changes which will create the ceramics or the glass or whatever is you are thinking of. Okay, and finally after that is done, you could do some polishing operations. Like here, for example, they are saying machining. It is possible to do like machining of some engineering ceramics. Then you could grind it, you could lap it. Okay, these are like polishing operations that you can do. So this is like the basic structure of uh, the process of manufacturing and making something with glass and ceramic. Okay, although this looks very technically intensive, the process of making it is has its root in craft. Okay, and it's a very very highly skill dependent process if somebody is doing by, let's say, some craftsman in doing it. But let's say in the industry, you could control the parameters properly to get what you want. So I'll show you parts of a video. I'll not show you the whole video because you need to go for your tests and all that. So let's just see parts of this video. Okay, right? So this is an arts, this is a video from, let's say, from Korea, and it shows the craftsmen who work in pottery in the country, and it's a very beautifully shot video, and it shows you some of the steps that they do. So this is like when you think about pottery, this is what comes into mind. Okay, can you hear me talking over the video? I mean, the video is just music, so it shouldn't be a problem. So I've reduced the video's volume a little bit so that it just is faint in the background, and I want you to hear me talking over it. Okay, so yeah, so the let me just go back just a little bit, and I want to show you. So this machine in the background that you see is used to make this kind of a thing. It's a piece of clay. It's an extruded solid clay. Okay. And so whatever type of clay that you have, whatever type of ceramic that you want to make, or a product that you make the clay, mix it with the necessary agents and all that, or additives, and mix it so that it's homogeneous and it has a certain uh, texture to it. Okay, it's smooth and it's not lumpy. It's I don't know if anybody has tried pottery, but that clay is like almost like butter. Okay, it's as it feels almost like butter. It's almost like that. Okay, slightly harder naturally, but yeah. Now this is thrown onto this disc, and then the craftsman goes into shaping the whole thing. Okay. uh, and then here, since the idea of this video is just to show you, like, just to make you appreciate the craft and the skill of the craftsman, but we are looking at it from the perspective of a manufacturing process. So this thing comes out, and after that they can. So I want to tell you about the process that happens after this. Till now, the clay is soft, so it is he's manipulating with the tools which are um, you know designed for that kind of a quality of material. As time progresses, you can see it in the chips that are coming out, that the clay will get slightly harder and harder. Okay, so let's go forward in the video just a little bit. And now the part is much drier. Okay, and this is like a traditional working method, or an artisan in Korea, and he is designing these pots after, let's say, or he's making these cuts and all that after the part has fairly dried. Okay, and all of these artistic things are done into the pot. Okay, just look at that, it's beautiful. So the way he's done it is, he's made the pot using two or three different layers of clay. Okay, so first layer is probably just dark gray, and then there's a white layer that he's applied to it, maybe painted over it when the whole thing was spinning on the disc, then the red layer, then the green layer, and so on. And when he later on carves it out a little bit, then those internal layers are seen, and that it makes it look so much more beautiful, right? So I don't know if he'll show. So just look at these patterns that are created. Okay, and I don't know if he'll show you the whole this thing. So this is what is created. Similarly, there are like so many other techniques that are there, and this video kind of goes through these techniques that are used in like traditional Korean earthenware craft work. Okay, so yeah, this one we should talk about. So this that he's applied to it, this is uh, is another type of, you can call it another slightly a slight variation of the ceramic only. Okay, it's called a glazing. Okay, so it forms a layer on top of the main ceramic body. So after it is fired, after this whole thing is fired, the inner layer will get naturally hard, and the outer layer, the parts that are white, maybe they'll get shiny, they'll have a certain luster to it. Okay, so that is glazing of the ceramic. And yeah, I'll leave this video. The rest of it is just different art craftsmen working on the different types of you know different types of pottery. So this one I really like, where he's once he's made the whole thing, he beats it to get this kind of very interesting form and all that, and all of this is there, right? Okay, I'll pause it, and let's go on to the next one. And this is like a continuation to that. Okay, and the same thing, these now I want you to see this process where after this is done, right, what happens. So this is some master craftsman. He's making the designs. Okay, there are so many traditional techniques in the Eastern cultures, uh, India included, in on related to pottery. Okay, so yeah, so as you can see, these different, you know, so he's made a groove with his tool, and he's put a layer of this glaze. So one glaze is white in color, the other glaze in, is darker in color. When all of this is fired, actually the chemical properties of the glaze and the pot itself changes, and it gets different colors than what it is painted with. Okay, so let's take a look at that part. Let's go forward. I want to skip all of this. It's there, the video is there for you. I want to skip all of this, and yeah, this is what I wanted to show. So when he's actually made the pot, when he's actually designing it, the glaze and all that looks like this. But once it is fired, this is what it looks like. Okay, so it gets a certain color, and all of these black things, rings, come out in a different manner. Okay, right, so I want to show you the kiln, the process of firing. Okay, so once the pot is made, so what they will do is they'll dip it in a slurry, which is a glazing slurry, which looks something like this. Okay, and yeah, so this pot is, you can see it's not, it's dried, but it's not cured yet. Okay, if curing is the wrong term, but just to explain it to you, I'm telling you. So now that, after that is done, it's dried again and then put in an oven. So traditionally, probably in Korean culture, the oven looks like this, but the oven design is different depending on where you are doing it. In the industry, it's definitely much different, but this is like a traditional oven. So pots are put in, and then the whole thing is sealed. Okay, and from a certain side only, they use, here in this case they are using wood or biomass to generate the necessary heat, but you can use it in any kind of oven. And the rod just now, yeah, this rod kind of tells you the temperature at which this whole thing is, right? Okay, so yeah. Okay, now after the whole thing is put in this kind of an oven, and traditionally it's difficult to control temperature. Look at this oven, right? So probably it's heated over here, and probably if air is forced from one end to the other, I don't know how exactly this works, but yeah, the idea is that internally it needs to generate so much heat. Okay, and so yeah, so this is how the oven looks like. And once a certain time has elapsed, the doorway probably is broken, and internally everything is glazed. You can look at the video and just see the glimpses of how it looks like, right? Absolutely marvelous. What amazing work. Okay, so those colors are due to the glazes and all of those things. Okay, the glazing also is the reason for this shiny outer layer. Okay, and depending on the temperature at which the green part is fired, you get these two differences between terracotta and ceramics. Okay, so terracotta is typically fired at a lower temperature. Okay, what you see probably in commonly in these Diwali diyas and all that. So those are also ceramics, but they are fired at a lower temperature. Okay, let's come to that question. So Shirsa is asking, what does the firing temperature depend on, or is it fixed for a certain type of clay? Yeah, let's okay. So let's discuss those things. Let's just conclude this. So ceramics, so although the beginnings of it are very traditional and very craft centric, but these are an immensely important engineering material, ceramic, and the modern uses of ceramic vary all over the place, right? So you have probably seen like a white colored ceramic knife. Okay, it the sharpness of such a blade will retain for a longer duration, let's say, than steel, but these are much more brittle than steel. So if it falls and if there's slightly undue pressure and all that, it will break. Okay, and then you in even in like ballistic protection armors and all that, ceramics is used. Famously, the disc brakes in some of the more powerful cars, such as this one is a Porsche movie, maybe, and most likely it's a Porsche, and there they are using ceramic brakes. It's very controlled, you know, uh, composition of whatever material that goes in over here, and I mean, I just by the look of it, I won't be able to say what type of ceramic it is, but yeah. Okay, right, right. Okay, so it's ceramics have extremely good electrical insulation and thermal insulation properties, and that's why uh, their use in such brakes are you know uh, it makes it perform so well. Okay, okay, let's see some of the ways in which it is manufactured. So next up, there are a few processes in which the ceramics are manufactured. The green part can be made. So one of them is, like, let's say you don't want to go through the whole process of hand giving the form by hand. So you could do something like slip casting. Okay, so instead of making the clay in the solid form, if you just add a lot more water, it will become a slurry. Okay, it will become flowy, right? So you could pour that into a dye, and pour it, fill it, remove the clay. I'm sorry, I hope you, yeah, okay. You can pour it, you can remove it, and you can pour it again, and slowly, what happens is that a layer of this ceramic slurry kind of forms on top of this dye, and that is dried and the dye is removed. Okay, you'd need to do some operations to cut out the necessary parts from all that, and that, once it is dried, you can it becomes like a um, green part, and then that is fired. Okay, so this is slip casting. Okay, uh so this is like the machine that I showed you in the background of that craftsman. This is what it looks like. This is how it works basically. So you have the a space where the clay is put together, and any kind of additives and all of those things are put together, mixed in to a certain extent, and put, and then there's like a screw. Okay, this diagram is not very clear, but this idea is that there's a screw which rotates and kind of pushes the material, and a slug comes out. Okay, so to remove any included air and all that, this parts of it you know is linked to a vacuum, so any air that is there is removed from here, so that air bubbles are not entrapped in the slug itself. Okay, so once you get the slug, you can have this kind of a process which is called jiggering. Okay, Giggering, jiggering. Okay, so the idea is that you have this kind of a tool, and this one is very close to the typical way in which ceramics sorry, pottery is done. So you take this clay slug, you place it in on the top of this die. You have a former, an initial die, which kind of gives a basic form to the clay. Okay, it pushes it down, and then you have this kind of a jiggering tool, which is of the form that you want. So let's say you wanted a form like this, right? So it has a negative form in, so it kind of wipes the clay around this die in a certain manner. You would add the necessary lubrication through using water or whatever, and based on that, you get that. Why is it called a slug? It's why the vacuum, I think I answered. So basically, if you don't have the vacuum, once the screw starts moving, some air may get included in this in this clay, and you don't want the air, because it may create like blowholes and all of those problems later on. Not blowholes, but inclusions of these air bubbles in the part itself. Okay, why is it called a slug? Well, be, uh, I don't know if there is a specific reason. Well, it's called a slug, right? There was no name for it, and then somebody suggested that we should call it slug, and I think the name stuck. That's my explanation to it. Right. uh, would the clay set if the same with the same properties if reused? Like if we break the pot and somehow make the clay wet again and reuse it, would there be loss of any properties? Once the clay has been fired, the properties totally change. It does not remain clay anymore. uh, Okay, so Chaitanya, the answer to your question is basically till the time it is a green part, it is not sintered, it is still clay. You could, crumble it and you could mix it with water, and you would still get this kind of a clay from which you could make a new pot. Once you fire it, internally, the chemical composition of the material changes, and it becomes a different type of a material. It becomes glass. Okay, so earlier it was, let's say, silicon. Okay, and after becoming glass, it becomes, let's say, silicon dioxide. Okay, similarly, ceramic, before it is in the ceramic form, it is aluminum oxide, let's say aluminum dioxide. Okay, uh, yeah, I think it's aluminum dioxide. I may be wrong in the chemical name of the whole thing, but the idea is that before it is fired, you can still make that. Why do metal lose properties? Shirsha is asking, is there a set of ratio for mixing clay and water? There uh, there is. So like, for example, you if you want, so it's just like making dough, no? So you can add certain amount of water and you get a certain hydration level of that clay, okay, of that dough. It's similar for clay. So you could keep on adding water. You could make a flowy clay, or you could make like a hard clay with little water. Okay. Yeah. Then, do metals lose properties too when recycled? Uh, well, I don't know what kind of properties are you asking about. So naturally, some mechanical properties are obviously lost or changed, right? But like inherent properties of the material, unless there's some addition or subtraction of uh, chemical elements from that, then I don't think it changes. I mean, it doesn't degrade, unlike plastic. So plastic, once you recycle, no, it degrades, but metal do not degrade as such, unless there is some during the process of recycling, another set of chemical compounds are added and all of that, and that changes the property. Okay, so yeah, so this process is called jiggering. And so what exactly happens? Why when the whole thing is fired? So let's say, so this we are discussing here. So let's say when the clay is there, these white lines kind of show you the let's say the structure of the clay before, and the blue part are the water. Okay, so so it says interparticle water. Okay, and so basically there's a lot of high percentage of water when it is in a more malleable form. The clay is in a more malleable form, and as it gets drier, there is some amount of water that remains. Okay, and in a green part, let's say before sintering, there's always going to be some amount of water, and that amount of water does not get removed without external help, without external energy supply. And once the whole thing is fired, then all the water from the material is expelled out. Okay, now this image is quite interesting, and it shows you these two strange things. Okay, one is standing up straight and one is like this, right? So these are used by ceramic craftsmen to understand the temperature of the kiln, the temperature of the oven in which the ceramic is to be fired. Okay, so these are made out of plastic, and what happens is that they are designed in a manner that once the oven reaches a certain temperature, then this starts melting and it stoops down. Okay, if the oven has gone too high, then the whole thing will melt away. If it is low, if the temperature is low than what this cone you know, uh, is designed for, then it will retain its shape. Okay, and if the temperature is just right, then you will have this kind of a situation. Okay, so this cone was removed from an oven which hit the temperature at which the cone was designated to stoop over at this, and probably that temperature is what was required to fire this oven. So here there are two states of the ceramic bowl. The first one is probably fired at a very low temperature, so hence and then this was probably fired at this temperature at which this happened. Okay, uh, so sometimes the firing is done in more than one stages, and so this process is of removing the water entirely is called bisque firing, and the last one is called glaze firing. That means the final step in which the ceramic becomes the part that you want is called the glaze firing process. Okay, and I will see what this is. Okay, so we are going to glass, but before that, I think I should answer Shisha's question, that is there any kind of temperature, no, any kind of temperature at which it should be fired? What does the firing temperature depend on? Is it fixed, or is it for a certain type of clay? Yes. So for clay with certain compositions, then depending on the composition of the clay, the firing temperature will change, and the firing temperature is done to a temperature called glass transition temperature. Okay, so the glass transition temperature is the point after which the chemical changes in the clay starts happening, which transforms it into, let's say, glass. Okay, in silicon to glass, let's say. Okay, sand to glass. Okay, so let's just take a look at just like we looked at how craftsmen work clay. Let's take a look at how craftsmen work. How craftsmen work, glass. Okay, so this is a video of a glass blower, and it's like a it's an amazing craft, right? And it's heavily skill dependent, and this guy is making a very interesting vase. Yeah, vase or vase. Okay, and you can see what is actually happening, okay, over here. So this girl from the other end, I shouldn't assume gender, but this person from the other end is blowing, and this person is holding and kind of rolling it along this, you know, edge. Okay, rolling the tube. What happens is that the glass is, when it is at this temperature, it tends to flow. Okay, so it tends to sag down. It's like, if you ever played with that, what kids play with slime, right? So if you hold it on one and it kind of droops down a little bit, so it's something of that kind of uh, property, right? And then that kind of falls down. It tends to fall down, and this guy with his hand, he rotates it in a manner to keep the shape uniform, and that's the skill that is required. Okay. Right. Okay. Where is my mouse? And let's see how what happens. Okay. And yeah, it's really really hot, huh, by the way. And you can see how the shaping process happens, and he uses various different kind of tools to give it shape. And as he's shaping it, the temperature of the glass reduces, and he strategically heats the glass at certain positions to uh, wait, give it the shape necessary. Now he's done with making this part, and he wants to start working on the other end, right? So he will join it with the other, with glass from the other, from this end, and he'll break away this part. Okay, so yeah, did you see that? Wait, he just made a score along the line and he just broke it. Okay, so it's just interesting how these craftsmen work the material. Okay, so you can see the way he's using the scissor, how soft this is at such temperature. And the craftsman over here, he really understands the material so well that uh, and especially the temperature at which it is, he understands it so well that he can manipulate it with the right tools at the right time, right? That's the skill. Okay, go forward. Let's go forward and see what he's actually made. And okay, let's see the end result. Okay, this is the end result, and it's, yeah, well, what can you say, right? Right, so let's let's take a look at how in the industry, what is the process of making glass, right? So let's say if you want to make like sheets of glass, then there are several processes. This is one of them, and this is the other. And the idea, so there are three that are shown here. The first one is where you would have a furnace from where the glass molten sheet would come in, and it would be floated in a bath. So this is some liquid which kind of, makes on which this molten, it says molten tin over here, but yeah, I mean, this is supposed to be glass, I think, or I may have made a mistake. But anyway, so this is the other one here. The molten glass is over here, and these two rollers, they kind of pull the material a little bit from this reservoir. Okay, they pull the material, and there are subsequent rollers which kind of take the material into other rollers. Okay, Chaitanya is asking whether the color is due to deliberately adding impurities in the glass. I don't know if you can call it impurities, but yeah, they are some agents which give it, some additives which give the glass a certain color. Okay, and then this is another way of making sheets of glass, where you have this molten glass over here, and the rollers kind of pull the glass away from the process. So I don't have the videos for these two processes, but if you do find, please put it on the OneDrive note, and everybody can see from there. Now, glass, there are several ways of making, like for example here, this step is how do you make like glass bottle. So you have a die where you put a glob of, you know, gob of molten glass, and you'd blow the whole thing from one end, okay, so that this kind of a bubble is created at the internally. So once that is done, you get like this. The reason this shape is different than this shape is because it's still molten, right? So it tends to sag, okay. And then this is called a parison. It is like a intermediate shape between the fully formed glass and this kind of a, you know, molten metal. So once that is done, it's put into another mold where air is blown in. It's naturally, it's heated, and it's air is blown in, and you get the shape of the die. That die is removed away, and you get the shape of the bottle, okay. Glass bottles are, um, if recycled correctly, and if recycled within the vicinity of its production and collection, then they are a much more sustainable material than, let's say, plastic bottles. Yeah. So yeah, because the but you could have plastic bottles also slightly more sustainable in some situations where, let's say, you need to collect the glass, transport to a very long distance to have it recycled and all that. Okay. So let me move myself this way, and these are two other processes. Let's say if you want to create something like earlier this used to happen. Nowadays everything is replaced by transparent plastics, but let's say these are some lenses of car headlights. Okay, so earlier they used to be made out of glass, and this would have been the process. Let's say you would have a top die and a bottom die, and you press it, and all the shapes or the features in the dies would be transferred onto the glass, and that would give it some desired optical properties. Similarly, there is one of these processes which is fairly similar to this, where or and even this, where you would have a mold where glass is put in, and you press it with a plunger, and because of that pressing action, the liquid will flow and kind of get into these kind of undercuts, and you get such a finished product. So these processes are possible. Okay. Right. So we almost finished this thing, and now we have something called joining processes, right? Okay. So let's take a look at very quickly what are the joining processes. I mean, we are not going deeper. There is so much to learn in the joining processes. For example, just like arc welding, no, simple welding, arc welding, that itself you could study for an entire lecture. Here I am just giving you like the schematic diagrams of different types of welding processes. Typically I would do it in the workshop, okay, so explain it to you with the machine and all that. But well, yeah, so this is the arc welding setup that you are most probably familiar with. You have a workpiece, you have a electrode holder, and there's an electrode. The electrode is made in a special manner. It is coated with something called flux, okay, and there is an internal rod inside the whole thing which kind of melts away and deposits itself uh, onto the surface of the workpiece. Okay, now the workpiece, when welding, the workpiece also gets is melted locally. Okay, wherever there is like this electrical arc which is created, the material, everything welds in that location, the including the electrode, and this kind of mixture, it creates a localized, let's say, alloy, okay, in that part, in that weld, and because of that, typically welds are sometimes more stronger than the work pieces themselves. uh, you could so you so this process can be automated where, let's say, the coating that is there, which is the flux coating on the electrode, I remove it from the electrode itself, and instead of having it coated, what I do is I put it in a hopper like this. So this is called a hopper, and it has the necessary tubing to transport the flux from here to, let's say, the place the welding is needed. And the wire itself, I could have it in a roll, okay, and which is fed through the appropriate mechanical controls and mechanical system, and it is controlled in a uh, proper manner with certain you know control setup, okay. And if there is so this whole thing is mounted on a rail, and that all of that can move forward, and you can have like an automated welding for very large products. So let's say these two work pieces need to be welded, so there's some kind of preparation that is done. So you can see over here there's some V grooves that are created, and the welding all happens in this V groove. The reason the V groove is there uh, is because the weld kind of assembles or pulls in this location and makes it much stronger, okay. So this is an automated process of arc welding, okay. Let me move myself to the other side, and let's see this another one variation. So here, instead, this one is a variation of arc welding where the electrode is not entirely consumed, okay. So it's a solid wire electrode. There's some ways of uh, so so there are two specific welding methods that are available in our works. Three. So no, two specific methods. One is arc welding, which is like this. The other one is TIG welding. TIG. TIG is tungsten inert gas welding. Okay, and this schematic is the tungsten inert gas TIG welding schematic. Why is it called a tungsten inert gas? Because the electrode that is used is a tungsten electrode which doesn't get eroded away. It does get eroded away very long after a very long duration, but it doesn't get fed into the weld like, let's say, in arc welding. Okay, and inert gas, the reason it's called TIG again, TIG, is because there is an inert gas which is used which is supplied when the weld is happening, and that inert gas is, let's say, argon, is creates oh sorry creates a shielded area where the electric arc can live freely, okay. The material itself is not oxidized. The place the base metal and the metal which is need to be joined, that is not oxidized because of the presence of oxygen in the atmosphere very close to it when it is very high, when it is molten, okay. So this is the shielding gas, this cloud that you see, and there's an arc which is created, and this arc is such a high temperature, this plasma is enough to melt the base metal and, let's say, the uh, two metals which need to be welded, okay. And this one shows a cross section where, as this whole thing moves from here to here, this is the solidified weld metal. This purple area is the solidified weld bead which is created. So I will share with you some interesting videos on welding and like the practical way in which welding is done, okay. And yeah, well, okay. So besides that, there are so many other ways of joining things. So here, for example, this one is an ultrasonic welding process in which there is a transducer which uh, you know supplies which provides ultrasonic vibration, let's say. So this is the direction of vibration, so it vibrates the rod, let's say this part, horizontally, and that friction creates enough heat at the tip to melt two pieces. Okay, so these two are the work pieces that are there maybe, and there's like appropriate setup which creates that. Okay, coupling is basically joining, okay, mechanical joining of two components. Okay, there's some coupling which is there. Okay, similarly this one also shows a different arrangement for this. Okay, right. Okay, this is very interesting. This is a fairly, I shouldn't say new, but it's like within this half century. Okay, so within the last 50 years, this has come forward, and this is called the friction welding. And the idea is that, let's say you have two rods, and you have one rod stationary and the other rod rotating at a very high speed, and you force one of them to the other. Okay, you force it with considerable amount of force, and you ensure that there's enough torque and enough force for it to not stop spinning, not to behave like a brake. Okay, and this kind of creates the a friction. The heat that is generated because of friction is enough to weld these material together. In fact, the forces and all are enough to diffuse the material into each other. Okay, and this is called friction stir welding, FSW. Okay, friction stir welding. Okay, and this is how it looks like. There's a small video that's there. Let's first take a look at that video, and then we'll come back to these other things. It's super fascinating.
By which high quality and high strength welds.
So this robot has this kind of a tool. This is like a tool steel. It's naturally much harder than the material it is trying to weld. There's really nothing there. It's all mechanical. That means there's considerable amount of torque in this, and this tool and this, let's say, are two pieces of aluminium, and they need to be joined at this location. Okay, now you see what happens.
Potentially difficult to weld alloys are possible.
So this
cutting edge technology is becoming an increasingly popular choice for manufacturing lightweight transportation
and
structures.
This is the weld that is created.
Aerospace, light rail, and marine applications. FSW was developed in the early 1990s by T.
So yeah, you see this? This is the weld location, and these two material are welded. They almost are kind of mixed together at that small location. You can imagine, for with such a amount of torque and force, no, you could the material itself behaves almost like a fluid. Okay, even at such cold temperatures.
Or the Welding Institute in the UK, it is considered a green process with no fumes or arc light emitted, nor shielding gas or welding wire consumed. So, Quebec-based innovation partner Crick developed this FSW system to utilize the Fennec M900IA robot to perform the welding process.
So you can see how it happens. It's fascinating. You wouldn't, I mean, it's so counterintuitive that
FSW
this thing is possible.
A large amount of downforce to plunge at the start and maintain tool orientation. So heavy-duty tooling is required to hold the parts in position.
Anyway, so yeah, well, you can imagine the kind of mechanical properties that are possible with this. Okay, let's take a look at these some other processes that are common welding processes. So this is the first one, which is called spot welding. You have two plates that are there, and there are two electrodes, and these two force a current is passed between these two electrodes, and a certain pressure is given. Wherever these two materials are joined, there's a small area where, no matter how much they are close, there's always some amount of gap. So within that gap, some electric arc is created, and that melts the material locally. Okay, and there's a spot which is created, and that becomes like a weld. Okay, this is how it looks like. Okay, you can see the electrodes are pressing fairly hard on the material. Okay, and the gap would probably be here. Okay, okay, the same thing, no, if you don't do it in a spot, but if you can do it in a seam, right? So, and the seam has these kind of rollers, and let's say these two electrodes you connect one after the other on this, right? So you could have this kind of a setup also. So you could weld long pieces. So such products can, so gas tanks, I don't think, no, yeah, I think even now it is made. The fuel tanks of vehicles can be made with such thing, unless of course polymers are also used. But yeah, this is a viable process. Okay, right. What did I do? Right, so these are different types of welding process. Let's not go into these. It's fairly simple and kind of self-explanatory. I would want you to go through the joining processes in the manufacturing, engineering, and technology book, and all of these are there, and you can read through and understand the various processes. Okay, and let's. I don't know what this is. I want to see also. I think this is like a so I let me go to this. Okay, so typically, just a second. So yeah, so typically what we do, this is what we do in the workshop. We gather all the students, and Jason from your, I think, senior batch was kind enough to do a video recording of one of those sessions. So I will thank you for coming. Wait, so this one I want some amount of audio. Uh, so today's session is about understanding the basic tools in the workshop. What are the various hand tools? What are the different types of tools, like for fitting, for. So you see Payal over here with a small bandaged arm, okay, and she cut the tip of her finger on one of the machines, okay, and yeah, so that should not happen when you come back and work in the workshop, right? I always give Payal's example. Okay, anyway, cutting and grinding, all these things. Okay, and there are three sections that we have divided. This is one section. This is related to fitting, like general purpose. A lot of the general purpose to hand tools are here. That is woodworking. Okay, let's let's skip on to the let's cut to the chase. Okay, there are some tools that I will explain, but this video is there. I mean, you guys should go ahead and see it. It's called a mallet. It has. So these hammers are not called hammers. These are called mallets, and the reason these are there is because the tip are much softer than metal, and they can be used to shape, sheet metal. Okay. Resin and plastic based, heads. So the idea is this one is used for sheet metal. So if you want to bend and yeah, just exactly what I said. He said what I said, right? Right. Let's. There's no point in me like talking over this whole thing, but I want you to. So wait, I'll see if there's. Yeah, so here's welding. Part 4 welding.
Benz circular saw.
Okay. Right, so you've seen welding, right? You've seen it in various places. So the idea is that you have two materials, okay, and the way you join those two materials is by melting a very small portion of the material. A localized melting of the material happens. So should I be playing this video on the video? So it doesn't make sense. So the video link is there. Okay, you guys go ahead and see, and this will probably give you a little bit of experience, unfortunately, since you were not able to visit the workshop. So probably next time when you come, and we'll do a proper workshop tour. We'll explain all the all the machines that are there, all the hand tools that are there. It may take like 2 sessions, but we'll do that in the next this thing. Okay. So right. Yeah. So the link to that video. Just give me a second. Right. So the link to that video is this one. Okay. So you guys can go and watch it at your own time. Right. Okay. So let's take a look at there's something is slowing down the system today. Yeah. See, I pressed it. So let's talk about wood. Unfortunately, we are not. I mean, in this course, there's no wood, but what I wanted to end the class with is at least the different types of joinery in wood. Okay. So, well, these are the different types of simple basic joinery in wood. You have a butt joint where one material is butted onto the other. You have a mitered joint. Okay. You have a half lap joint. Okay. You have a tongue and groove joint. I don't know if it's very clear over here, but the idea is there's like a small tongue that comes out and there's a groove, receiving groove on the other end, and these two planks can be joined to form a larger plank. Okay, mortise and tenon is something like this. And newer ways of joining, no, if you use like some CNC, not CNC, but some hand tools, you can create these kind of grooves on the material where you can fit small pieces of wood like these, which are called biscuits. Okay, and these biscuits can kind of join the wood together. Okay, all of these, it does not make sense for you to just see images and yes, how that. No, it should be either made or you have to come and see somebody working on it, then only you learn. Okay, so these are just there for your reference. And there are several different ways of joining. These are like the famous dovetail joints because they are difficult to make. Okay, this one is called the box joint. Yeah. Okay. And yeah, Pranay, if you have a question, you can type in about flat glass panels. Okay, and these are called dowel joints. Well, so it's all there in this. Yeah, I mean, okay, so we'll just stop here. Okay, we have not gone through wood at all. I mean, these are like just the images of various types of joineries. And the reason these are there is because it gives me scope to ask you at least one more question in the test. Okay, I can say, can you give me a schematic of what is a dovetail joint? Okay, how would you make a dovetail joint? There's nothing to explain. I mean, there is a lot to explain, but you have to have the material in front of you, the tools in front of you. I mean, it makes little sense with just the images there. Okay, however, what I will do is I will put in the OneNote drive some interesting videos about woodworking where these kind of joineries are explained. How do you make these joineries? That is explained. So what kind of things you need to take care of, those kind of things are explained. Okay, and if you want to learn more about wood, there's a specific woodworking and carpentry book that is there that you can take. Okay, would all of these joints need nail screws, or some joints can do without? Totally, some joints can totally do without the need for screws. Famously, most of the 16th to I think 18th century, I think much before that also, most of the old Japanese architecture uses uh, like these kind of very interesting joinery of wood to get the structural strength in the building. you can actually search for Japanese wood joinery, and you can find some very interesting ways in which they are done. Looking at it, you can appreciate it, okay, but when it comes to actually do it, no, very simple things like this box joint over here, where is the box joint over here, that also is very difficult to make. Okay, so yeah, so all of this remains for us to explore. And yeah, that's it. That's the overall topics covered in the class, in the syllabus. These are the overall topics that we have mostly covered. In the next module, we have some extra topics that we thought we would cover in the course, and we can do that. So if you have any questions, so it looks like it's already 4:30, and if you have a class or an exam from 5, I would like to end here and give you some time to kind of get the breather, get some come back to that frame of mind. So we will end the class here, and I will send you a mail asking you about some not free time, but a slot where we can do like a one-on-one session, or if it does not happen, then we will do it in the last module. Okay, and that's about it. Thank you so much. If you have any questions, I'll wait, I'll drink water. If you have any questions, then please type it in. Okay, Chaitanya, I don't know who George Nakashima is. Yes, Shirsa, of course. Why not? Are you scared of doing assignments? See, we already planned 10 assignments, and I think 2 assignments got clubbed together. 4 assignments got clubbed together into 2 assignments. So yeah, we will have 2 more assignments. Okay. Yeah, thank you so much. When is the submission for assignment 7 and 8? Good question. We had 31st as this thing, right? As the submission date for the last assignment, right? So we will have one more week. 7th is the last date for submitting the assignment number 7 and 8. Okay. So 1 week after whatever we had planned earlier. I don't remember. When was the submission date? Last date for submission for this thing? Okay. I'm not doing Inktober this year. Yeah, I could not manage you. The first day itself, I kind of, almost gave up. There are a lot of things that I need to do, and I mean, the earlier time when I tried it, every piece I kind of spent around 2 hours, near about 2 hours, starting from, let's say, collecting reference, thinking about the idea, uh, collecting reference, and doing the piece. No, it took around 2 hours, and I could not spare that much time in a single day. But yeah, maybe next time. And I kind of realized it doesn't have to be Inktober for you to do sketching every day, no. So once I find myself in a better mental space, I think I will do this 1 month challenge. It doesn't matter even if the month starts on 15th, right? 7th November was for 5th and 6th. Okay, yeah, good. Thank you for that. So if 7th November is that, then we'll do like 14th and 15th, 1 week after that. Okay, even if it coincides with the module, it doesn't matter. Okay, so you submit during that. Okay, 1 week after that. So you get 1 week extra for these 2 assignments. Okay, I'm giving you a lot of time for these assignments, these 2 assignments. 5 and 6 and 7 and 8, you are getting a lot of time, right? So remember to not put it up for very late. Okay, and yeah, okay, if there are no more questions, then thank you so much. Thank you for that, Tejas. Yeah, let's see if I can do it again. Yeah, Chaitanya, we get the joke, man. Okay. Yeah, okay. I'll see you guys through email in the and I'll send you some information and we can get back later on. Okay. Thank you so much. Ending the stream now. Ending the stream.